The role of AI in geotechnical analysis. Welcome to Blueprint to Reality, the channel where civil, structural, and geotechnical engineering concepts are explained clearly and practically. In today's video, we'll explore the role of artificial intelligence in geotechnical analysis, how modern AI tools are revolutionizing the way engineers understand and predict soil and rock behavior. From machine learning models to predictive analytics, you'll see how AI is improving safety, efficiency, and decision-making in geotechnical engineering projects. 1. Introduction. Geotechnical analysis is traditionally based on field data, lab tests, and empirical methods, which are often time-consuming and subject to uncertainty. Artificial intelligence, AI, provides advanced computational methods to analyze complex geotechnical data, recognize patterns, and predict ground behavior more accurately. 2. Importance of AI in geotechnics. AI helps engineers analyze large and complex data sets, quickly predict soil and rock behavior under different conditions, detect anomalies or potential failures, optimize design and construction strategies. This reduces risk, enhances safety, and supports cost-effective solutions in projects such as foundations, tunnels, slopes, and embankments. 3. Machine learning techniques. Supervised learning uses labeled datasets to train predictive models applications, predicting settlement bearing capacity, slope stability. Unsupervised learning identifies hidden patterns in unlabeled data applications, clustering soil types, detecting anomalies. Reinforcement learning. AI learns optimal decision-making strategies through trial and error applications, adaptive control in excavation or tunneling operations. 4. AI and slope stability analysis predicts likelihood of slope failure based on historical data and sensor readings, integrates with real-time monitoring from inclinometers, piezometers, and surface deformation sensors, supports early warning systems and preventive measures. 5. AI and foundation design predicts settlement and bearing capacity for various soil types, optimizes foundation dimensions and material usage, reduces reliance on overly conservative assumptions. 6. AI in tunnel and excavation monitoring monitors ground movement and stress distribution during tunneling, detects anomalies early, and recommends corrective actions, improves construction safety, and reduces project delays. 7. Integration with geotechnical instrumentation. AI models use data from sensors such as piezometers, inclinometers, fiber optic sensors, automated total stations, real-time analysis, allows predictive maintenance and adaptive design changes. 8. Data analytics and predictive modeling. Big data analytics processes historical and real-time geotechnical data. Predictive models forecast potential failures, settlement, or liquefaction, helps in risk assessment and informed decision-making. 9. Benefits of AI in geotechnical engineering. Faster and more accurate analysis, early detection of potential failures, cost-effective designs, and construction improves safety and reliability. 10. Challenges and limitations. Requires large, high-quality dataset, skilled personnel needed for model training and interpretation. AI predictions are probabilistic and should be validated with engineering judgment. Integration with traditional methods may require calibration. 11. Future trends. Fully automated AI-driven geotechnical monitoring systems, integration with BIM and digital twin platforms, real-time AI decision-making in construction sites, AI-assisted adaptive design under uncertain ground conditions. Conclusion. Artificial intelligence is transforming geotechnical analysis by enabling faster, safer, and more accurate predictions. By combining AI with modern instrumentation and data analytics, engineers can make informed decisions, reduce risks, and optimize construction performance. AI is becoming an essential tool in modern geotechnical engineering. If you found this video useful, like, share, and subscribe to Blueprint to Reality for more insights on civil, structural, and geotechnical engineering topics. Let us know in the comments which topic you'd like to see next, and continue learning how engineering ideas move from blueprint to reality.